All right, folks, we are going into the last topic in chapter 5. Now, it's actually part of 5.6 and 5.8. So you're going to have two different pages for work when we get to the exercises. It's part of 5.6, part of 5.8. It's called area of triangles. So instead of just solving triangles we know nothing else about except some pieces of them, we're going to look at solving for their areas. With a right triangle, remember, you can always use 1/2 base times height. But with a triangle that you don't know is, or if you know it isn't a right triangle, or if you're not sure, you can use these formulas. All right, so that's what we're going to be looking at today. So let's head across to the notebook. And I'm just going to give you the formulas first. And again, they're going to be broken up as to what information you're given. Those three pieces of information, again, that we need about any triangle. So let's look at the first one. First one is if we have two sides and the included angle. All right, so we have that. When we have two sides and included angle, for example, if we look at a triangle, and just as a reference, if we have something like this, and so if we have two sides and included angle, that could be A, B, and then it would have to be something that doesn't match, so it's C, right? So we have AB and angle C. If we had this, what we would do for the area would be 1/2 times the two sides, so in this case length A, length B, and then sine of the angle, in this case angle C. So 1/2 AB sine C. Now, the other ways we could have this, we could have A and C. If I had sides A and C, the included angle would be B. Again, no pair. When we have an included angle, it's no pair. When they make a pair, remember, it's non-included angle. So area is 1/2 AC sine B. And finally, we could have BC as our sides, and that would mean angle A. And then area would equal, let's see, what do we got? 1/2 BC sine A. So we have that. Though that's one situation. Two sides included angle, we use this. 1/2 times the two sides times the sine of the angle. All right, let's do another one. So, and we'll do some examples of these in a moment, folks, just so you're aware. I just want to get out what we have here. Now, you could also have given to you two angles and a side. All right, so remember, in essence, you really are given three triangles here, aren't you? So you're going to have to solve for that third angle in order to use this. But if you're given two angles and a side, you can find that third angle. I should say third angle. All right. I just messed it up again. All right, sorry about that. That third angle. All right, you're going to have to find that. Now, if we have that, this one's a little bit different. It's similar, so you got to be careful here. All right, we're going to have the area equal to, again, we're going to have angle A, B, and C and a side. So if we have side A, for example, you're still going to have 1/2. You're now going to have A squared, and then you're going to have this fraction, this rational expression. Now, what you're going to do is that if this was side A, sine of angle A will go on the bottom. All right, so it's going to match whatever this is going to be the bottom. And then the other two angles, we want their sines multiplied on top. Again, you've got A, B, and C, remember, so we're going to do this. So what else could that look like? If we had angle or side B and then the other two angles, we'll find the third angle, and then we would use 1/2 B squared times this fraction. And I always start by putting this down at the bottom because it's the matching one. And then we'd have sine A sine C here. And finally, the last way or form this could take is if we had side C and two of the angles, we could find that third angle and multiply this. And we would have that to work with. All right, so two different things so far. We have two sides and included angle, and we use the 1/2 AB sine C format, or two angles and a side, where we find the third angle, then we use area equals 1/2 A squared, and then the rational expression with the two angles that don't match the side on top and the sine of the other angle on the bottom. All right, so that's two of them. Last one that we can do is if we are given three sides. If we're given three sides, there is a formula we can use that is alternately in different texts called Hero's formula or Heron's formula. After as the story goes, a sheep herder in Greece. A lot of our old math from the Greek and Roman times came from sheep herders because they had a lot of time to sit in a field and think, and they would draw in the dirt all their math. But this last one, again, either Hero or Heron's formula, is written this way, where A equals, and I'm going to write it out and then we're going to talk about the pieces of it. It's going to be S times S minus A, and you don't know what S is yet. Don't worry about that. We're going to get to that in a minute. S minus B, S minus C. So it's all three of these things, these four different quantities, S, S minus A, S minus B, S minus C, multiplied, and then take the square root of it. Now, what is S? S is what we call the semi-perimeter. And if you remember what that is, gold star to you for remembering your geometry, because you did use this in geometry. Semi-perimeter is equal to 1/2 the perimeter. All right, so what we need, again, is the perimeter. Well, we have three sides, so we can always find the perimeter, right? In this situation, when we're given three sides, we find the perimeter, take half of it, and we get our S value. And then what we do is put that on S, that value, times that value minus each of the sides, whatever quantity those are, multiply them all together, take the square root of it. So these are our formulas that we can use. Now let's look at a couple examples. All right, let's look at this. If they ask you to find the area of the triangle, all right, that's going to be our directions for this problem. Find the area of the triangle. And so they haven't told us anything about the triangle except they're going to give us some pieces. Whoops, triangle. I just can't stand that looking like that. Sorry, guys. It's going to take a second. All right. All right, so find the area of the triangle. Those are our directions. And let's say they give you this. If they tell us that, first example, B is equal to 14, A is equal to 130 degrees, and C equals 19. So what do we have here? We got to look at this. This is two sides, and what kind of angle? Well, it doesn't match either of these, so it's got to be the included angle. So two sides and included angle, we're going to use, in this case, area is 1/2 times each of these sides times the sine of the angle given. So in our case, this is 1/2 14 times 19 times sine of 130 degrees. So punch all that in your calculator, and you should get 101. Well, again, yes, we're going to go to the nearest tenth. So we are going to talk about this as units squared. Always make sure you use your units here. And we need to designate that this is square units just because it's an area. So we do need units squared. You could also write that as U squared if you wanted to. All right, so that's the answer. Once you get the idea of what you have, then you just got to remember the formula, plug it in, and go. It goes pretty fast. These are not long, drawn-out problems where we need a lot of extra pieces. Let's see. Let's do another one. Let's see. We give you A equals 28. B equals 18. And C equals 25. So that's a 2. 28, 18, 25. We got three sides. Given three sides, we go back to Hero's formula, right? What do I need first? Well, I need my semi-perimeter. My semi-perimeter is going to be 1/2 of 28 plus 18 plus 25. So S becomes, what is that, 35.5. So 35.5 is our semi-perimeter. So now what do we have to do? Well, we have to plug it into our area formula. Area is going to equal square root of, well, we start out with that, 35.5 times, let's just say 35.5 minus 28, that's 7.5, times 35.5 minus 18, that is 17.5. And finally, 35.5 minus 25, that is 10.5, right? Yeah, 10.5. All right, and multiply this out, take the square root of it, and you should end up with 221.2 units squared. So we have another answer. All right, again, pretty fast. These go relatively quick, right? You just got to have those formulas available in order and know which one to use given the information you're given. One last example. Let's look at this. We have C given to us as 4. A is 37 degrees, and B is 69 degrees. So we've got 2 angles and a side. So as soon as we see that, first thing we should do is find out what angle C is. Angle C is going to be 180 minus 37 degrees plus 69 degrees. So that's 106. So this would be 74 degrees for angle C. So we have all 3 of our angles and our side. We can use area equal to 1/2 times that side squared times this thing where I put the sine of, well, C was our side, so I want sine of 74 degrees on the bottom. On top, I'll have sine 37 degrees and sine of 69 degrees. And again, whoops, 69 degrees. There we go. All right, so with this, again, I'll usually start inside here, and I would probably do sine 37 times sine 69, divide it by sine 74, multiply it by 16, or I would just figure out this is 8, 1/2 of 16, and multiply it by 8. And you should end up with here 4.7 square units. And we're set. That's how we use each one of those guys, and that's it. That's all we're doing with these areas. You're going to have some more practice for this, and then we will be finishing up the chapter with the second half, which is, I believe next is 5.3 and then 5.5 and unit circle stuff. So have a great day and see you tomorrow.